Hello everyone, I'm Sam Miller, and today I will be talking about databases and focusing specifically on PostgreSQL, which is one of the more popular open source systems used in organizations today. So databases are a key part of almost every technological system. It's because they often hold sensitive data and the security for it is very critical. So this presentation will show how PostgreSQL works and where its weaknesses are and how to make it safer through a few simple hardening steps. So here's what I'll be going over today. So first I'll explain what a database is and go over the main types. Then I'll introduce PostgreSQL and give a quick overview of how it's set up and configured. And then next I'll show how to install it on Linux, describe common security risks, and explain 3 basic hardening steps which make it much more secure. And then I'm going to wrap up with key takeaways and my references. So what is a database? A database is simply an organized way to store information digitally. It's managed by a database management system, or DBMS, which handles storing, updating, and retrieving said data. So databases help ensure that the data is accurate, consistent, and easy to access when needed, so you can access it wherever you are, whenever you are. So they're used everywhere. So banking, healthcare, cybersecurity logs, even social medias all rely on databases running on behind the scenes. So there are 4 main types of databases: relational databases like PostgreSQL or MySQL. These use tables and SQL, obviously, to organize structured data. And then there is NoSQL databases. These handle flexible or what are known as unstructured documents, unstructured data, so like documents or graphs. And then there is hierarchical databases, which organize information kind of like a tree with a parent and child records. While network databases hold much more complex many-to-many relationships, relational databases remain the standard because they're more reliable, they enforce rules, and are widely supported in a business system. So that is the one we'll be talking about today. So PostgreSQL is an open-sourced relational database. So it's known for its stability, standard compliant, it's very rich in features. It runs on port 5432 and uses TCP for its connection, so making it as secure as possible. And then there is PostgreSQL, which can handle traditional relational data, but it also supports JSON indexing and replication, so it works well for both structured and flexible data. It can run both on Linux and Windows and is used by a lot of large companies, small startups, and universities. It's very flexible to use. Because it's open source, anyone can install it and modify it, but that also means you're responsible for configuring it securely. So PostgreSQL's configuration is handled through 2 main files. It's PostgreSQL.configuration file. It's control settings like network connections, performance, and logging, and it's PG_HBA configuration, where controls who can connect and where they can connect from and what authentication methods they use. So we are going to be dealing with these 2 files when we are configuring our servers to make it a little more secure. If you don't, it'll have issues such as the ports closing and not showing on the in-map scan. So a few key settings includes the listen address, which defines which IPs the database will accept connections from, and then the listening port, which is usually 5432, and then password encryption, which determines how user passwords are stored. So these files give admins full control over how PostgreSQL runs and how secure it is. So it's very important to make sure that we are configuring it correctly. So to install PostgreSQL on Linux, you're going to run the sudo apt install PostgreSQL. So pretty straightforward. But after that, this is kind of where the technical side comes in, where you're going to want to configure the files. So you can edit these on PostgreSQL configuration for the service settings, PG HBA for the authentication. and then make sure to save your settings. I have made this mistake before where I forgot to save it properly. And then you're going to want to restart PostgreSQL to make sure that it's running on the new configured settings that you have set it to be. So by default, PostgreSQL listens on port 5432. So this accepts local connections and doesn't use encryptions. So it requires the extra setup needed to make it more secure for real environments. So we have to make sure that it's actually using end-to-end encryption. And for PostgreSQL, there is no quote-unquote secure port like we have seen in the past. So we have to make sure that the one that we have is secure as possible. So PostgreSQL, like many databases, can be vulnerable if left with just its default settings. So some of the biggest risks that I found through my research are weak and default passwords. So these are easy to guess. You can, a threat actor could break in and access some data, which we don't want to happen. Port 5432 being open to the internet, which allows anyone to try and to connect. Obviously, there's not much we can do. It's not like we can unconnect it from the internet, then it's just unusable. So we have to find a nice middle ground for that. And then unencrypted traffic means that credentials and data can be read by attackers. And then overprivileged accounts, where users have more permission than they may need. So this is a common problem in many environments and just can be fixed with some simple configuration changes. But if not fixed, it can lead to a big security risk. So we have to be aware of even the small things, even if they seem a little overkill. So when you first install PostgreSQL, it's designed to be easy to set up. So, it's not really secure. It often trusts local users without passwords. SSL is turned off, and it listens for all network connections. And that's great for testing in a lab, but unsafe in production. So our goal is to change these defaults so that only trusted users and systems can access this connect more securely. So the first hardening recommendation that I have is restrict network exposure. So this is the first and easiest way to improve security is to limit who can reach the database. So think of it kind of like locking your front door for your house. Only specific people should be able to get in with the right key. So in the configuration file, you can change a setting called listen addresses to accept connections only from safe IPs like your internal network or local host. So for example, our listen address for the Linux ends in .1.5. And then next use a firewall, which we are using IP tables to allow connections from only the app server that needs access and block all others. And so by doing this, port 5432 is invisible to the public internet. And this single step removes, the biggest attack path for threat actors. The second hardening recommendation is strong authentication and least privilege. It's to make logins more secure and limit what users can do. So in the PostgreSQL configuration, set the password encryption to SHA-256, a stronger password encryption, and that makes SQL a little more secure, and it secures hashing methods for passwords. And in the PGHBA configuration, define who can connect or something like that. So like host all, and then you list the IP address and then make sure that you are using the correct authentication after that. So just making sure that you're enforcing the secure authentication as well in the other configuration file. So each person or application should have their own user account instead of sharing one. So this gives users the minimum permissions needed for the role, nothing extra. So for example, a developer may only need to read access while admins can make changes. So if a password is stolen, the attacker can only access that specific role's limited permission, so we can kind of mitigate the risk a little better. And this helps keep your data more safe and prevent one account from compromising the entire system. And then for the third hardening recommendation is TLS encryption on port 5432. It's to encrypt communication between the database and users. So by default, like I mentioned before, PostgreSQL sends information in plain text. So that can be intercepted if someone is monitoring the network. So to fix that, you can enable SSL or TLS encryption. So in the configuration file, uncomment SSL equals on, or type that in if it's not in there already. And then you're going to want to provide a certificate and private key. So that is something that you probably would have developed earlier on as you were working on the ports. Make sure you quote the correct file or it's not going to access it and it's going to show that the port is closed. So this proves that the server's identity and encrypts the data a little more. So make sure that is configured correctly. That's usually the issue that I run into the most. And then finally, in PG HBA configuration, set connections to require SSL by host SSL, and that forces all traffic to be encrypted. So once TLS is turned on, passwords, queries, and results are all protected in transit, just like HTTPS protects web traffic. So to summarize all the technical stuff we went over, PostgreSQL works well out of the box, but it isn't secure by default. So it runs on port 5432, which is often open to the internet, uses weak or no authentication, and doesn't encrypt its connections. But we have some pretty simple steps that are kind of straightforward with the 3 hardening recommendations that I provided. So number 1, kind of limit who can access it. Number 2, require strong passwords and restrict permissions. And then finally, the third, which is encrypt connections with TLS. And you can make it much safer and ready for a real world environment. And these changes can take less than an hour to apply, but can prevent some major security incidents later on. Good configuration is the first line of defense for any database. Just make sure that you read carefully what you are inputting, because then it can make it much more than an hour, which again, I have done before. It's a big task to unwind where you went wrong. So take your time, make sure that you are hardening correctly. And our final slide is our references. So all configuration examples and technical details in this presentation has mostly come from PostgreSQL official documentation, Ubuntu's server guide, and resources like Oracle, IBM, and Geeks for Geeks. These references explain every setting in detail. So if you want to try this on your own, or maybe research a specific topic that I talked about a little more, here is the references that I have used, and that wraps up my presentation. Thank you all for your time.